Hello DC Circuit students. In this short video demo, we're going to demonstrate Ohm's law using our solderless prototyping board and a 9-volt battery and our multimeter. So for this experiment, we're going to use our multimeter with voltage measurement, and we are measuring DC voltage. So if you're getting an odd number, one thing to make sure of is that you're not on the wrong scale and you're not measuring AC. If that's the case, your meter is trying to do an averaging and find probably a root mean squared value that may not be appropriate. So make sure your meter is set to measure DC, since we are using a DC source. A battery is the ultimate DC source, as opposed to maybe a rectified half wave or other type of source. So the first thing we're going to do is see what our open circuit voltage of our battery is. And for this, I'm using a little connector to make it easier to connect my leads. And unfortunately, for using my solderless proto board, this is stranded wire, which will not fit down in the sockets, and we shouldn't even try. So we have a workaround for that, but we're going to start by just measuring our source. So remember that when you measure voltage with your meter, you're presenting a very high resistance series connection in this case. So there's very, very little current coming out of my battery. And so the way an electrochemical power source like a battery works is that the more current it gives you, the lower the voltage it will give it to you at. So we're seeing what's called open circuit. The meter has a very, very high resistance, so it's almost as if it's an open circuit, and I'm seeing about 9.4 volts. So depending on how large the resistance is in our circuit that we're going to build, we're going to get something less than that at the battery. So we're going to use the same resistors that we used before. We're going to use a nominal 1000 ohm and a nominal 500 ohm, and we're going to put those in series and then see what happens in terms of voltage drop over each one. So to make things easier for our circuit build, we're going to use the power rails again, and this time we're going to actually be bringing current into a circuit rather than just measuring, and we'll provide some leads to do both. So connecting, I'll just put this out of the way. So I'm starting by using a jumper to go from my positive power rail over to my circuit building portion of my board, and now I'm putting my two resistors in series. Now if I wanted to check to make sure they really were in series, since it's really not good to clip to the side of a component and measure it, I'm going to make myself a few measurement points where I can just clip my meter leads and measure between those points without having to clip them to the component leads, which are a little more fragile and can bend during the measurement, which is not a good thing to have happen. And I'm also going to make sure that I can come out to my other power rail. So I'm pretty sure I have all of this connected the way I want it. So what I can do is I can start by looking at continuity. So I can make sure I indeed have everything hooked up in series the way I want. So what I'm assuming is that I can bring in some voltage, bring in current through from my battery here. It's going to flow along this rail. I'm going to bring it over to my circuit. It's going to flow through this resistor, which is in the same line on row 54 to the other resistor, and then back out to my negative power rail and back into the battery. So I'm going to use my ohm meter just to make sure that I have indeed hooked this up. This should be continuous, and it should give me something around 1500 ohms, a little bit less, nominal 1500. So I know that I'm continuous and my two resistors are in series. So before I ever bring any power in, I can make sure that the circuit is built the way I want. Now, since I can't connect directly with these stranded wires, I'm going to use a small workaround, otherwise known as the double-ended alligator leads. These are not the best practice because they are very, very temporary and an easily dislodged connection, but if you're building a simple circuit on your desk, it's not moving, and you're careful, this is definitely a versatile way. It certainly beats trying to put a stranded wire into your protoboard, which you shouldn't ever try to do. Okay, one thing of note, a 9-volt source, while this is not connected to grid power, there is a fair bit of energy in this battery. So something that I would have made sure of before I hooked this up was that the current that would flow through those resistors squared times the resistance, the total power dissipated, was within the rating of each resistor. That would be a safety check that I would calculate first. I know that they're within the range of what I'll get. Certainly if I smell anything getting hot, I will immediately disconnect my battery. That's something you should always do, but you should calculate ahead of time and know that it's not a problem. So the first thing I'm going to check, and in fact I'm going to give myself a couple more measurement leads. I'm going to measure the effect of current flow on my source. Because I'm pretty sure that my battery is not going to want to give me that full 9.4 volts, and in fact it's probably not even going to give me the nominal 9. So I'm giving myself a couple of more test points. There's lots of test points here. So I'm going to keep an eye with my meter. I'm going to measure the total circuit voltage with current flowing. So this is going to give me the battery output to the circuit under load, and we're going to have a lot less than 9 probably. Not too much. Definitely less than the open circuit of 9.4, but not too bad. So 9.27. So if we were to do an Ohm's law calculation, we'd know that our entire series circuit is being powered at, nominally 9.26 volts. So that's the total circuit voltage. Okay, so now let's see how that's being divided. Voltage divider, think voltage divider, for each resistor. So I'm leaving the battery connected. There's still current flowing. I just took away my meter. So I'm going to see what the voltage drop is over my first resistor. I can't see the color bands very well, and I can't remember which resistor this was. So I'm dropping 6.26 volts over the first resistor. I know I have the same current flowing through both resistors, and I know Ohm's law is V equals IR. So given that I have a total voltage drop of 9, or I'm supplying the circuit with 9.27, I know this is probably my nominal 1K resistor. And so I can measure the voltage drop over my next resistor. 2.989. If I added that to the voltage drop over the first resistor, I should get that 9.27. Let me check that again. 9.26 that's powering the whole circuit. So what I've done is effectively, I'm going to unplug the circuit so that I'm not continuing to drain my battery. I've created what is known as a voltage divider. I've taken the entire circuit voltage and I'm dropping part of it over one resistor and part of it over the other. They're in series. The same current is flowing through them. I could actually take these leads that I used for measurement and connect them to a whole nother circuit, which would then be supplied with that 6 and a bit volts that was being dropped over that resistor. So that's a real powerful way of applying Ohm's law to actually create other little power supplies for yourself. So that is it for this demonstration of using your solderless protoboard to create a series circuit and demonstrate Ohm's law with the use of a 9-volt battery.